This is for Dr. Lee. You certainly have presented a very complex and complicated project. You had the metro station, this historical building that had to get relocated, the road diversion. You mentioned a major program change, this auditorium that got built over the metro station, a lot of different things happening. From your standpoint, what was the most challenging part that you had to solve?
Most challenging part is, I think, the technical side. As long as you continue learning, working with the team, it's resolvable. The most challenging is always and ever-changing design process, and the time constraint is very important. Also, you have to understand, really find out the priorities. Most of the time, you can do design 24 hours every day. You continue producing drawings, calculations. However, the priority is, as a designer, you not just look at it, I finished the paperwork, or meet the code practice. A lot of engineer becomes a model engineer. Put everything directly into model. If the model doesn't show red, bingo, fine, I'm going to issue the drawings. Actually, it's how you look at the solutions. Rationale the solutions, how you can do the better. Especially schematic concept is key. Nowadays, I think everybody rushed, especially in the very fast, no patience pace, which is not very good. We have to, as a designer, we have to get our philosophical mind in place. We have to really manage the process. Sometimes we have to manage the clients, manage the pace in order to focus and to think of the best solutions. At the end, the construction and the cost effectiveness and really the good design shows how we focus, how we concentrate on the best design solutions.
I have a question for Men regarding the composite shear wall. And I think you made a very interesting presentation. I have a couple questions for you. One is, obviously for all kinds of composite shear wall, the one very important question is, what's the distribution of force between the concrete and the steel? I mean, in other words, how does the force transfer between the steel part and the concrete part? I'm wondering whether you have done any research on this part. I'm not talking about the finite element analysis. I'm wondering whether there is any real test on this part. The second question is that you introduced the system with composite steel plate wall with vertical stiffeners and openings. It seemed to me that this system is very similar actually to a wide-fringed steel reinforced shear wall. So I'm wondering why you took all the trouble to use this system instead of a wide-fringed reinforced shear wall. Between these two systems, I can imagine the steel plate reinforced shear wall will be more difficult for construction. So I'm more interested in what's the benefit of the steel plate shear wall system so that you chose to use steel plate shear wall system. At the same time, you have these openings and the vertical stiffeners to make it work.
We have studied between steel and the concrete. So the steel and the concrete can work together. Thank you. And firstly, I will say that Mr. Fan is I'm a student of Mr. Fan, so thank you for your question, and your question is very good. I will try my best to answer your question. So because Mr. Fan is not here, so I hope my answer will get your point. The first is that how the steel and the concrete the force pass. Is that the question?
Yeah, I'm wondering how, say for example, if the load is applied at the top of the wall, right? What's the percentage of force goes to the steel, and what's the percentage of force goes to concrete? How do you calculate that? And I mean, based on what?
And the crossing is very exact. The point, the crossing, I think, is very important for the shower. And by far, we are concentrate more on the ability of the shower. So this how the steel and the what part of the steel and the concrete bear the force. It will be a good point for we to research next. By far, so we don't have some research on it. It is too hard for by now.
Regarding the shifting of historical building, it's a nice and challenging project you have done. My question is that whether you observed at new place when you shifted the building any unrealistic distortion at any place of the building?
Yes. Actually, yes, the building has been stiffened very much before any sliding activity started. And once it's relocated to the new place, it sits on the newly constructed, the piled foundations. So actually, the vertical settlement won't have any impact. There won't be much vertical settlement within the limitation as well. So at this moment, we continue monitor the movement of the building. It's not a problem at all. But the challenging coming is we got to do the top-down construction for the basement underneath the historical building. Yes, it's all been said, the design program, the precautionary measures, and the design analysis all have been done. So we're looking forward to that, the final part to be completed. And later on, there'll be building conservation. There will be some specialty architect to design the interior as well for the future clubhouse use.